This is Honors Geometry 7.1 to 7.4 review. I thought we would just do one of each type of question just to give you a quick review of what we've covered so far in the right triangle unit. First thing we talked about is the Pythagorean theorem, good old a squared plus b squared equals c squared. And I recommend that you just identify your c, your hypotenuse first. So I know I'm missing my c in this case. And it doesn't matter which one you call A and which one you call B. I usually think of the smaller as the A and the other one as my B. And we're missing a C in this case, the hypotenuse. So I get 9 plus 36 equals C squared. That gives me 45 equals C squared. We're going to square root each side. And again, we don't want a decimal. Let's try to get a simplified radical. So I know this is 9 times 5. 9 is 3 times 3. Now it's prime numbers. We're done. I have a pair of 3's. So the pair of 3's is going to come outside. The 5 is left over without a partner, so that's going to go back inside. So we know that the length of the hypotenuse is 3 root 5. The next thing we talked about is the converse of the Pythagorean theorem, saying you could do the Pythagorean theorem and find out what kind of triangle you have. So your largest side is your C, your potential hypotenuse, and your other two sides are your A and your B. So we're going to say 6 squared plus 8 squared, does that equal 9 squared? We're going to find out. 36 plus 64, does that equal 81? Obviously not. We get 100 equals 81. That doesn't work. Then what you want to do, we know it's not a right triangle. Then you want to look at your hypotenuse. In this case, the hypotenuse is too small. And you can sort of envision that. If you have a hypotenuse that's too small, that's going to make this an acute triangle. If the hypotenuse was too big, it would be an obtuse triangle. And obviously, if the Pythagorean theorem works, we know we have a right triangle. And just as a quick reminder that the sum of any two sides has to be greater than the third. Otherwise, it doesn't even form a triangle. So you might want to check that. All right. 7.3, we talked about similar right triangles. We dropped the altitude from the right angle to the hypotenuse of a right triangle. It split it into two smaller triangles, and we found that they're all similar. So we can set up our big triangle, our medium triangle, and our little triangle. I like to have them all facing the same way, and I sort of exaggerate the long leg so I could see what's what. So my original triangle, we have the long leg is X, the short leg is Y, and the hypotenuse, we're just going to add those together and get 35. I thought I'd up it a little bit and give you several unknowns just to make it more interesting for you. Our medium triangle is right here. I can see that my hypotenuse is my X. I can see my long leg. The long leg of the medium triangle is always a piece of the original hypotenuse. So I can see my long leg is 20. I can see my short leg is Z, and the short leg is always the altitude of the original triangle. Now our little triangle, there you go. Looks like the short leg is 15. The short leg is always the piece of the original hypotenuse. The long leg is always the length of the altitude of the original triangle. And my hypotenuse is right there. It's Y. All right, so we've got a couple choices where we want to start, what we want to do. We want to make sure we stick with just one variable, one unknown. So let's see what we're going to do. Let's do 35 is to Y as Y is to 15. Hypotenuse is the hypotenuse as short leg is to short leg. So we're going to say 35 is to Y as Y is to 15. Cross multiply, we get Y squared equals 15 times 35. Gives us 525. That doesn't look too bad. 525. We're going to square root both sides. And again, let's go ahead and just use a radical because we know how to do that. That's 25 times, which I like because it's one of our perfect squares, 21. We know this is 5 times 5. So that's our pair. 21 breaks down to 3 times 7. There's no pairs there, so we're going to put those back in. So we now know that Y, the length of Y, is 5 root 21. I just put those back in and multiplied them. At this point, you could do whatever you want. If you like Pythagorean theorem, boom, you have two sides. Anytime you have two sides of a right triangle, you can use Pythagorean theorem. If you like the new shortcuts we talked about, use those. I'll use one of those just so you can use that, see that if you like our new shortcuts. On this one, we can use what I call that triangle shortcut. That says the length of the altitude is the geometric mean. It's the middle of our snowman of the two segments that form the hypotenuse. So if you like that shortcut, go ahead and use it. Otherwise, go back to your three triangles that we have. So I'm going to say that 15 is to z as z is to 20. Cross multiply, we get z squared equals, is that 300? 20 times 15. 300, and again, I recognize that as a multiple of a perfect square. That's going to make our work a little bit easier. So I'm going to take 300, and it's 3 times 100. We know 100 is 10 times 10. You can break those down, but as soon as I see a pair, I go ahead and take them out, save myself some work. So I know it's 10 root 3. So our z is 10 root 3. Again, at this point, if you like Pythagorean theorem, you say, hey, that's easier for me. You can do it right there. You're looking for the hypotenuse of your medium triangle. If you like your three triangles, go back to that, and we're looking for x. Look for an opportunity to use only x. Okay, you can use some of the given information. And just to mix things up a little bit, maybe I'm going to use the around the corner rule if you like those shortcuts. Okay, so if you remember the around the corner rule, you need the whole length of the hypotenuse, you need a piece of the hypotenuse, and you need the leg that's around the corner. They call that the adjacent leg, adjacent to the segment. So if you like that around the corner rule, the leg that's around the corner is the middle of your snowman. That's the geometric mean. So to use that, it doesn't matter which one you put first. So I'm just going to say 20 is 2x as x is to the whole hypotenuse, which is 35. And if you remember doing geometric mean, we'd have something like this. The gear ratios, what's proportional to 20 and 35. So we're going to cross multiply. 20 times 35. Get 700. Ooh, that's a nice easy one. That's a multiple of 100. So we're going to like that. Let's go ahead and square root. And let's factor that. That's only going to take us a second. That's an easy one. So we have 700. So I know that's 7 times 100. And 100 is one of our perfect squares. We're going to take that 100 outside, or 10 outside. And that 7 stays inside. So it looks like the length of x is going to be 10 root 7. All right, we have one more lesson to talk about. And those are our special right triangles. And the idea is they're supposed to be easy. Okay, if you'd rather use Pythagorean theorem, you can certainly do that here. Okay, so this is our 45, 45, 90. And I remember the shortcut is the legs are the same. It's an isosceles right triangle. And the hypotenuse is the length of the leg times the square root of 2. So there's no work involved. I know the legs are 12, so my hypotenuse is 12 root 2. Boom, easy as that. And then we had our 30, 60, 90. Across from our 30, the shortcut was, that's our short leg. We call that x. The hypotenuse was twice as big, or 2x. And what we call the long leg across from the 60 was the short leg times the square root of 3. And I thought I would choose one of the uglier ones just so you can see that. So I know that x root 3 equals 9. They have to give us one of the three sides, and that's the one they chose to give us. So I know that x root 3 equals 9. I'm looking for the short leg, and I'm going to double it to get the long leg. So we divide each side by the square root of 3. So it looks like x equals 9 over radical 3. We know we're not allowed to have that in math. That's one of our rules. So we're going to rationalize, which means multiply the top and the bottom by whatever radicals in the denominator. So you get 9 root 3 over the square root of 9, which gives us 9 root 3 over 3. And before you type that into Schoology or move on, let's go ahead and simplify this fraction. 3 goes in there once, 3 goes in there 3. So we know that x where our c is in this case, is 3 root 3. Easy as that. And then for the hypotenuse, it's 2 times that, 2 times 3 root 3. So we multiply this together, can't go inside, remember that, and we are done. Super easy. Please go ahead and try the practice problems. Give me an email if you have any questions. Thank you.